Coming up on FTC Recap, members from the team Robot in 30 Hours join the show as we break down the latest headlines, have a discussion about their ultimate goal robot,
giving you a voice,
making it loud our own way.
Welcome to the fun.
First Updates Now FTC is produced in partnership with the Orange Alliance. Make TOA your place to go for FTC team stats and event results at theorangealliance.org. And also, viewers like you. We need your help to keep fun loud, live, and independent. Help us by visiting our Patreon to pledge your support at patreon.com/First Updates Now. You can also support fun live on Twitch for a few bucks a month or by linking your Prime account for free and clicking subscribe.
Welcome to FTC Recap, where you get the latest breakdown and discussion of what's going on in the FTC community. From First Updates Now, I'm Ishan.
My name is Kate, and I'd like to introduce our guest, Joe and Kenneth, from alumni of Team 7129, the Robo Raiders. Every year since 2017, a group of alumni from Team 7129 builds a robot in 30 hours right after kickoff. These robots have often had the architecture of world-class robots. Thank you for coming on the show.
Thank you for having us.
Yeah.
So now we're going to jump into our headlines. There was a new FTC SDK release for Ultimate Goal very recently, and it includes some new features such as TensorFlow detection for the starter stack, Vuforia for the Ultimate Goal targets, implemented into the SDK, and some other bug fixes. Perhaps the one I'm most excited about is some bug fixes with the Rev IMU. It was notorious for saying crashing during initialization, so they've claimed that they've fixed those problems. This version of the SDK will be mandatory for teams to use at competition, even though there is no inspection this year. Any features that stood out to you guys? Anything that you're looking for in future versions of the SDK?
I really think it's pretty amazing. I just think it's pretty amazing that they're actually implementing some TensorFlow as well. That's just a really powerful tool for teams to use. So it's cool that they've got kind of more options to work with.
Yeah, I definitely think the IMU fixes will be useful for a lot of teams.
Yeah, I think TensorFlow was first implemented in Robotics when teams were trying to sense the gold mineral when they had to pick out the gold mineral out of the two silver minerals. And a lot of teams didn't use it because it was implemented so late into the game. But now that TensorFlow is in there relatively early on, this is week 3, I think that a lot of teams will definitely use it. All right. Kate, you want to move on to the next topic?
Yep, so Team 3954 Pink the Future from the Netherlands has been participating in Robot in 1 Week Challenge for the past 4 seasons. This year they made a robot that could intake the rings and put them in the small goal. I think this robot's kind of unique compared to some of the other robots in 3 days or the robots in 1 week we saw this season, since it didn't have a shooter. It definitely put out some ideas for teams that weren't going to approach the shooter this year and just go for the little low goal. So what do you guys think about this approach to the game in this robot design?
So their intake had to be one of the coolest things. They use the surgical tubing intake, but I think they use very stiff surgical tubing. So it picked up those rings really quickly. And then the fact that they didn't put a shooter, I think, was a bold move. I know they're known for making top-notch robots, and I think they're trying to show that you could have a low goal scorer that beats out a shooter if it's more reliable than a shooter. And for those of you who haven't seen this robot, it has a little stick which the rings fall onto, and then it launches them into the low goal and just places them in there. Awesome.
I think that's definitely a good kind of idea for teams that might not have access to rings early on to try to build a system that can score low goal, because the ring dynamics aren't going to be the most important thing to get the low goal, but something like the high goal is going to have that specific anti-mark component.
Yeah, I mean, we'll talk about it, especially once we get to breaking down your robot, but I know a lot of quick prototyping teams had a lot of trouble with that. Moving on, the Team 9794 Wizards.exe released a video tutorial going over the physics of a shooter for the Ultimate Goal season. The physics is greatly simplified and is a rough approximation so that a rookie team could understand what's going on. There's been a lot of focus on software and hardware tutorials like building and programming, So I'm glad that like teams are starting to make tutorials about the theory. I was not involved in making this tutorial, just heads up, but I thought it was pretty cool that my team was putting this together. Did you guys use physics when you're building a robot?
Yeah, definitely. Especially just for calculating like motor torque, how much you need to be able to accomplish something. That's just crucial to a lot of different parts of FTC. And I think it's pretty amazing that we're starting to get more resources like that where teams can pretty easily just have access to kind of starting to understand more the math behind how things work.
Yeah, I think physics could be a big part of the game this year since a shooting game.
Yeah, for sure. All right, want to talk about the next robot?
Yep. So Team 12973 Robotics from Mako, Texas made a robot in 30 hours this season. Things going on. Two mechanisms that stood out to me most were the wobble mechanism and the shooter. I really like their idea of the surgical tubing grabber for the wobble mechanism, and I haven't really seen anything like that this year. I also thought it was interesting that their shooting ramp was basically on the ground instead of most teams I've seen have had shooters that have been up the ground a little bit. And even with the shooter ramp being so low to the ground, they were still able to shoot the power shot targets. So do you guys have any comments on this design?
Yeah, it looked like a noose to me, the pickup for the lava goal. And I think Tyler's showing it on screen right now. That thing looks scary. I know a team that did a similar mechanism for picking up the sky stones because with a mechanism like that, you don't need to like line very well. You just need to rope something in, and it's pretty obvious whether it gets in, making it easier to drive with. Not sure it's going to be the best mechanism, but it's definitely a cool mechanism. And if you're a rookie team, it looks like how they've built it is pretty simple with Go Builda and Rev Parts.
Yeah, I know that kind of mechanism was used during Velocity Vortex to try to grab the cat ball as well.
Yes, it was. And I mean, it was pretty successful in Velocity Vortex, especially because it's easy to drop things with it. And this year, where you're not allowed to launch those wobble goals, having something where you can just quick release it would definitely be helpful.
Something I want to ask real quick is that this robot, where it shoots from, seems to be much lower than some of the other teams with the angle. So what is your opinion on having this sort of exit angle versus having a shooter maybe up a little bit higher?
I mean, one limitation as a result of that is that you've got your mechanism lower, so there's less space for electronics or other components down low, whether you have odometry wheels or just like your electronics down there. And I know we made one robot one year where we had our mechanism really low inside the robot, and that caused our electronics to be shoved into the side panels, which was not great for maintenance for what we were doing. So there could be some limitations as a result of that, but it seems to work effectively. So
yeah, I think it makes intaking and all that a little bit easier since they don't have to transfer the rings as high up, but it definitely does add some limitations of like spacing on the robot.
Yeah, also you just have to shoot higher, right? You have to shoot an extra, 15 inches high, so you got to put more energy into it, and that's energy that you could save. But then again, you don't have to intake as high, so it could be much easier to build an intake and transfer mechanism. So it's all trade-offs, and I think that's the name of the game for FTC anyways. Now, this robot was cool. So for those of you who are big FRC fans and watch FRC reveals, the team 1986, Team Titanium, they were finalists in 2017. They built a half-scale robot of their 2013 Ultimate Ascent robot that shot frisbees. The robot's not FTC legal, so they're using FRC parts, but they even modeled the bumpers. The size is very similar to an FTC robot, so it could definitely be used. But there are some issues with it, like it is meant to be fed by a human player, like was in the 2013 game. So definitely some things to improve, but I still thought that this was pretty cool.
Yeah, I definitely agree. Kind of reminds me of the Team Beta back in I think Block Party also had a very similar robot with the FRC bumpers, but FRC robots really have a lot of cool features that can really be used and adapted well for FTC.
Yeah, for those of you who don't know, Team Beta was like one of the best teams back in like 2013. I think they won Inspire in 2014 or something like that. No, 2012. They won it the year before they came out with that Block Party one. And they it was a one-man team, I think, that year, and he just decided to make an FRC style robot for FTC, and so he put bumpers on it to get the entire FTC FRC aesthetic. So still a pretty cool robot. Kate, you want to go on?
Yeah. So Team 18304 Ultraviolet is a rookie team from Georgia, and earlier today they started their robot in 24 hours challenge. I think it's cool to see all sorts of teams trying to build their robot as quickly as possible this season, with teams of alumni, rookies, and veterans. Ultraviolet is about to hit their halfway mark for their challenge. They started at 10 o'clock this morning, and so far they've managed to build a drive base, and they started testing with intakes and wobble mechanisms. What do you guys think about all the different teams doing robots in 3 days this year?
I think it's a really great exercise for teams to try to do, because there's always the desire at the beginning of the season to try to build something really fast, and maybe you get locked into a design that's not optimal early on. And so by doing a robot really, really fast, you can see the limitations of your design more quickly and choose a better design for the entire season.
Yeah, one of our fellow fun hosts, Egan, he's actually one of the team members of Ultraviolet. I don't know if he was on stream right now, but we're going to raid their channel after the show, so make sure to stay afterwards to get a glimpse of what they're going to be doing and releasing. Pretty exciting stuff, and I know Egan is super excited about it. All right. There was a big update from FIRST recently, and this was definitely something that came as a shock to me. FIRST recently announced that they do not have any in-person events planned for FRC and will reevaluate in January. They have currently released new challenges for FRC teams to work on during the season and have reduced registration fees for the season. One of the cool challenges that they've released is a design your own game competition, which I would love to be a part of. It sounds awesome. But they also do have challenges like you do infinite recharge at home and other stuff like that. Any thoughts on this announcement? Did you guys get a chance to take a look?
Yeah, I got to read through at least part of it. I think it's really good that FIRST is kind of putting forward that effort of trying to come up with new and different ways to keep teams involved, even when they can't quite operate the same way that they would have liked to. So I think that's really cool that they're kind of coming up with some new ideas and ways for teams to keep working.
Tyler, what did you think of this? I mean, we all have FTC backgrounds, so there's only so much we can say. How was this received in the FRC community?
So I think it's kind of twofold, and I'll try to be as quick as possible here. So the whole, like, the things like the design challenge and the infinite recharge at home and the innovation challenge, I think were received quite well for things. And it'll be interesting to see how that is implemented. And it would be cool to see what different designs come out for stuff as well. One of the things that was very confusing, and they did the same thing when COVID started hitting the FIRST standpoint, is you had separate regions making announcements for things, and then all of a sudden FIRST comes in and makes a blanket announcement for something. And this is the exact same thing that happened when COVID started in March. You had regionals canceling individually, and it took like forever until FIRST made an announcement. And FIRST even made an announcement like a week and a half ago about course championships and that sort of thing. And then they come out and say this. So to me, that's very confusing on why they would say that and then come out and say, oh, by the way, no events as of right now. And then on top of that, I'll just wind up here. You have several other regions right now are actually saying that they are planning for in-person events. Now, FIRST hasn't ruled out in-person events. They just have for now. But regions like Michigan and South Carolina and many others have come out and straight up said, we are planning on having in-person events. Plan for it. This is what, yes, we need FIRST blessing to do it, but we're planning on having it come the beginning of the year. I'm sure that might change depending on how COVID is, But it's just interesting to see that like there's not a unified message between the regions and what First HQ is giving.
Yeah, I think a lot of it also carries down to FTC. First has been unified on terms of FTC and saying that there is going to be virtual and in-person events and pretty much let the regions decide. So that's been really great on our side. I think a big part of the championship announcement may have been FTC teams that were not planning on competing or were planning on dissolving or going to VEX, wanting a championship. But this is all speculation. Let us know what you think in the chat. Why first release that championship announcement and then this announcement right after?
So every year FTC has an official forum where all registered teams can ask questions about judging, field setup, and most importantly, the rules for the game. The forum for the Ultimate Goal season opened up teams now have the option to ask their questions on the forum. So answers to questions and updates for the game will be posted on the forum throughout the season. So make sure your team is keeping up to date with all the latest updates on the forum.
Were there any rules that stood out to you guys when building a robot in 30 hours that were confusing and you would have liked a forum clarification on?
I think there's definitely the big one that a lot of people are talking about of just the launch distance. It does seem like it would be pretty difficult for the referees to actually enforce that or to be able to check that during inspection. So it'll be interesting to see if they maybe make some changes to that rule as the season goes on.
Yeah, no answers have been posted up till now, but definitely interesting to see. So now we're going to jump into our next section. Let's discuss that. For those of you who just tuned in, joining us are Joe and Canuck. Can you pronounce it again?
Canute.
Canuck, alumni from Team 7129. Every year since 2017, alumni from their team have worked on building a robot in 30 hours right after kickoff. Could you tell us a little bit more about the Robot in 30 Hours initiative?
Sure. So for the past few years, we've been doing this Robot in 30 Hours. And so, Canute and I graduated from the FTC program, and we've been in university. And so this is one of our projects that we kind of come back together and we work on. And, we kind of do it alongside with the FTC team Robo Raiders as they're kind of doing their initial strategy analysis or whatever. We just kind of took some parts and went into a different work shed and just kind of worked on stuff in there. But it's been going on for, this was our 4th year, I guess.
And could you talk a little bit about the origin of why you wanted to do it? You were telling me a little bit about some of your inspiration before the show.
Yeah, one of the things we really saw kind of as we were kind of in the program, we saw a few teams starting to do this, but mostly it was the Robot in 3 Days was more of an FRC thing. And I believe we saw Eagle Robotics Experience was doing something similar where most of the team had graduated, but they still wanted to be involved in the program in some way, both being able to build some robots and then help support the community. And we thought that was really cool. They kind of took that time to come back, work on a robot, and then just go back to school immediately after. And we thought it would be a great idea to try as well. So that was kind of the inspiration behind it of just seeing that example and hoping to kind of do the same in the future. It's been fun.
This year, Robot in 30 Hours made an awesome robot for Ultimate Goal. If you have any questions for them, please tag @FirstUpdatesNow in the chat, and we'll make sure to get to it. But to start us out, specifically about this year, could you talk to us a little bit about the strategy that went into building this robot?
Sure. So the original, the strategy that we kind of went with was we want to shoot as much as we can into the high goal. That was kind of the main goal that we had. And so to do that, you need to pick up the rings and you need to be able to fire them. And that's basically as far as the strategy kind of went. We decided against doing anything with the Wobble goals for scoring onto them because of just the point difference that you would have during that time. We decided it wasn't worth adding a whole nother mechanism to do that for our build. that we were working on. And I mean, to an extent, in the actual game, it's unless there's some kind of weighting to the end game, there may not be much incentive, at least from what I've seen, to scoring onto the wobble goal if you're capable of scoring in the high goal.
Yeah, a big thing that we try and do with our strategy every year is this is especially helpful for newer teams, is to look at all the different scoring objectives and see how much they're worth, and then kind of rank them based on how difficult they are as well. And you can often see some things that start to stick out. This year, it was just shooting the rings. If you're able to shoot into the high goal, it's just worth a lot of points for your time, especially if you can do it quickly. So it's definitely worth doing. So a lot of our strategy kind of revolved around that. Also, kind of looking at the endgame tasks for this year. Since endgame influences ranking, which is kind of a new thing, it can sometimes be pretty important to work on those. So that's kind of where we also went with going for lifting the wobble goal outside of the arena.
Awesome. Kate, you want to go on to the next subsystem?
Yep, so let's talk about your drivetrain a little bit. It looks like you guys chose a Mecanum drive for your robot. Why did you go with the Mecanum? And if you had more time, would you have gone with something different, like a 6-wheel drive?
Yeah, we really do love using the Mecanum drive, especially for this year because there's so much maneuvering to actually get lined up to shoot. Being able to strafe side to side was super helpful. The 6-wheel drivetrain is really helpful if you want something simple that you know will be consistent, but I think it was just really helpful to be able to use the Mecanum drive this year and just have that maneuverability.
Mm-hmm. All the other designs we've done so far for Robot in 30 Hours have been, 6-wheel designs, and this was the first time we did a Mecanum. So I think especially for this game, it was very applicable for what we were doing. The other games we could kind of get away with, like a skid steer drive like that, but this year definitely, especially if it's going to be a remote event that you're going to be playing at mainly, having the extra maneuverability without any real downsides of getting pushed around is a valuable thing to have this year.
And for your drivetrain, what was the gear ratio and where did you build it from? Are those Go Build a wheels? Could you go into some more technical detail about it?
Yeah, I think the drivetrain is about a 1.75 to 1 gear ratio, going off of I don't remember exactly, but it's up a little bit from just a standard 1-to-1. So trying to get a bit of extra speed to go around.
And those were Go Build a wheels, yeah.
Yeah, Go Build a wheels. Find them to be really smooth and work well. And the team just happened to have some lying around. They dyed red from the past, so got to keep the aesthetic going.
Awesome. Perhaps the thing that everybody's most excited for this year is a shooter. And for your shooter mechanism, you went with a dual wheel flywheel. We've already had a question in the chat. Why did you pick the 2-wheel flywheel over a 1-wheel flywheel? And that was from Pat Bother.
That's right. So I was the one who worked on the shooter system. And so one of the reasons we went with the 2-wheel shooter was because we started designing a 1-wheel shooter. And I didn't really want to build out a whole gear train in order to get the speed up. So we were using what's on there right now on that robot were two, like a 3.7 gear reduction, those orbital boxes on there. And so by putting 2 of them together, we were able to get the speed we needed to launch the rings properly, or our version of the rings. And when we had just one, it was kind of anemic when it was shooting. It wasn't going to go far enough, just being a direct drive. And so in order to keep simplicity for what we were doing during our time, we didn't build out a gear train to kind of work with that. I think there are very, very good reasons to use the single flywheel, just in terms of you only need one motor. You're going to get that spin as a result of that if you build out the system properly. With the 2 wheels that we had, basically the physics behind it was if we spin it really fast, it'll fly farther. And that's kind of just twice as far with 2 wheels or something like that. It was the napkin math. So that was kind of the idea behind there. But for teams that are going to be building stuff this season, build out a two-wheel system if you want to prototype it. But the problem that we ran into with that was just, there wasn't spin on there to keep the disc level as it was flying. There was no kind of gyro action going on there, and so it could kind of, flip through the air. So
Yep, makes sense. I mean, I talked about this on air earlier. Having that spin helps keep it stable due to the moment of inertia. So having a two-wheel can be disadvantageous, but you guys got it to work to some extent. Do you want to talk a little bit about the accuracy that you had with your shooter?
Yeah, it was a bit interesting. When we were first doing the testing, we were just kind of feeding the rings in along a flat surface, and that was actually surprisingly accurate. Even with just kind of the small amount of spin that we had, it was working pretty well. The difficulty was when we actually started implementing it in the robot itself. Our feeding mechanism wasn't quite as smooth as we would like it to be. It's kind of one of those things you happen to have in 30 hours. What can we get working? And there's actually some kind of catching as it was fed into the shooter. So sometimes it would fly perfectly straight and wonderfully, but then other times it would come out with more of that wobble. So I think it's definitely worth looking into at least testing a double wheel flywheel. But if you can go single wheel, it is very helpful to get that extra spin and make it just a bit more accurate.
And one thing that I was talking to some of the team members, and they played with the robot when they got their actual rings in, and they were saying that it was a lot more accurate than our homemade foam rings that we had made, just because it wasn't catching to the same extent because they were just a little bit thinner.
Right.
And as a result of that, it flew better, and it was, I think they told me it went in 7 out of 10 times they launched it instead of like bouncing out, and I was like, that's much better than what we were seeing during our practice runs. So I don't know, there's some value to prototyping at the very least those double flywheel designs.
Great.
So for the wobble mechanism, you just used extrusion basically on with a claw on the end. Do you want to talk a little bit more about that and what the thought process was behind your wobble mechanism?
Yeah. So something that's always kind of funny with the robot in 30 hours is I'm kind of the go-getter. We want to do everything we possibly can, whereas Joe's kind of more the conservative. Okay, what can we actually accomplish? So our main purpose was to try and get as much shooting done as we could, and then we ended up having a little bit of extra time at the end before we needed to clean up and film the reveal video and everything and head back to college. So we were like, okay, what can we add in the last 2 hours or so? And we're like, well, what's kind of next on our priority list? And putting the wobble goals outside the field is really worth quite a lot of points, and it doesn't take a very complicated mechanism. So we were like, okay, if that's what we want to go for, let's just slap something on there. So we were able to just grab some extrusion, put it together in the last few minutes, and it works pretty well. So I think that's really something teams can learn from, is some things can really be done in a pretty quick amount of time. So just being able to make something that's very simple, just a piece of aluminum extrusion with a servo on the end, can really get you a lot of points without needing to be very complicated.
Yeah, and the mechanism that we're using for that, we weren't quite sure how to kind of move it around, because it was going to need to have a gear train, but the team apparently had this really insane gearbox that they had. It's like a 256 reduction or something like that, if I recall correctly. And so we just were like, okay, so it just has this huge box on there. We just slapped it on. It was a direct drive off of that. So if teams have access to get some of those gearboxes with their motors, then having a system like that can be really simple. Obviously, a gear train is going to work well for that too, and it's going to be a little more accessible. But that really big gearbox allowed it to be done in a very quick amount of time.
Awesome. And so now we're going to go on to what I thought was probably the most successful part of your robot, which was your intake. It was able to pick up those rings super cleanly. Went into designing that intake. What would you recommend other teams do when building an intake like what you have?
Yeah, before the reveal came out, we were looking at some past FRC videos from Ultimate Ascent, looking kind of at their frisbee launchers. We were thinking it might be a frisbee game, so we were pretty close. And we just really liked some of the ideas that we saw there of kind of the drop-down intake, being able to come up over the top of the rings. And that's kind of an idea we've used in the past. So we kind of started out with that, but had an issue where the rings wouldn't always kind of come up onto the ramp. So kind of underneath on the back, we added, this is one of Joe's ideas, of adding just a pair of wheels with some backspin. So the first set of wheels pulls the ring in, and the second set of wheels kind of lifts it up, while the first set pushes it in. So it's just kind of a way of making it a lot smoother to actually come inside the robot than having to worry about coming over a lip. So I think that's really where we kind of got the inspiration and how we developed it.
Do you think you have an advantage to having it fold out instead of just having it stationary at the beginning of the match?
I think the advantage to having it fold out for us was, it made it a little easier to get more, Q inside the robot for the rings that we had, the way that we were just kind of bringing them in, not stacked, but just like in a line, I think that kind of helped it. And just in most games in general, having a collection that's extended outside the front of your robot, while it does make you a little more vulnerable and a little more, less durable for a system, it allows it to be a little more effective for picking up, in our experience at least.
I know the Masquerade robot back in the Cascade Effect year, they had a really amazing intake that a lot of teams drew a lot of inspiration from. And one of the key things about it was it kind of dropped down in front of the robot, and they were able to suck in balls by either coming in from the front or even just turning their entire robot and catching a ball at the side. So it's kind of difficult to be able to do that with the rings, and we thought it was at least worth a try. And we were able to do that to some extent, but I think that's also kind of an advantage of the longer intake mechanism, is sometimes, in addition to just be able to drive straight over a ring, you can have a bit more leeway by coming in from the side as well.
And so is it just being held down by gravity, or do you have like something forcing it down?
Just gravity, yeah.
And do you think that like was an advantage because it allowed it to fly up and down, or would you probably had it forced down?
We did do a bit with some rubber bands originally, just to kind of help pull it down, and we found that to work pretty well in the past. But yeah, definitely having a bit of flex helps quite a bit. We've seen at different competitions in the past, the mat of the actual field can be on different surfaces, so your robot might sink in a bit more, or if you got a really heavy robot, it might also sink in, or if you got a really light robot. So you're going to have kind of some variation in the field that you can't always account for. So being able to have some of that flex in the actual intake can be really helpful.
And then there was a question from Black Star 4H Robotics. What did you use on the intake to hold the rings? Is that a specific part or something you fabricated? I'm assuming like the ramp area.
Right. So we had the entire ramp, intake, and queue kind of system is all run off one motor, right? So the green and gray intake wheels spin, and then off of those gray wheels, we had just some Robotics timing belt, kind of pulley gear. I don't remember what the names for those guys would be, but we just took some rubber bands and just put them on there and just ran it up to right where we were going to feed it into the system there. So, it would be better to have actual timing belts on there because the rubber bands were very sketchy. Probably the sketchiest part of the entire design, just in terms of our testing and our work. But, it kind of worked. It was very accessible for what we had. And, they're just some black rubber bands we had lying around. And we're like, okay, let's try this, guys. And it kind of worked, so.
All right, Kate?
So what would you recommend teams to look at when designing their robots this year? Are there any challenge that you ran specifically when doing your robot in 30 hours?
I think a big one is just being able to kind of some problems we had with the intake. Originally, when we just had that pulling the rings straight into the robot, try and get them over kind of a lip, And that was pretty difficult and prone to some errors, especially, again, with variations in the field. If the base of your intake isn't at the right height, you could have some issues with that. So being able to kind of design in a little bit of flex into the system, or have maybe some wheels to kick the rings up, just little things like that can really help quite a lot.
Joe?
And also, I would say that you got to make sure that your transition from whatever feeding mechanism you have to your launcher is smooth, because that was where the inconsistency came up with our design, for this year. So you got to make sure you're keeping the transition components for your systems in mind as you're designing, because you can make like one part that's a great shooter and a great collection, but bringing them together can kind of cause that difficulty. So you got to try to plan with that from the beginning for how you're going to make that work.
Awesome. So just some other general questions about Robot in 30 Hours and your experience in it. How do you guys mock a field without game elements? How do you get measurements that are close enough?
That's always been kind of one of the fun challenges of Robot in 30 Hours. Back when we first did, before we'd graduated in our last year of First Tech Challenge, we did the Velocity Vortex Challenge, Robot in 3 days. And what we did there, we didn't have access to one of the center goals at the time, so we just used a box that we had lying around that we thought was about the right measurement. And this year, we were able to kind of go a bit more advanced. One thing that's really helpful is AndyMark puts up the CAD files of the entire field on their website. So actually for the rings, is kind of an interesting story of we didn't know what kind of foam they were, but from AndyMark, we had both the CAD file and how much the rings actually weighed. So we were able to download the CAD file, see what the volume was, and then calculate the density based off of that. And then look up, okay, how dense are different kinds of foam? And then we were able to, Joe's brother was able to find some foam seating pads or kneeling pads that we thought were about the right density. And we just cut them up and made some rings.
Mm-hmm.
So, and actually, that's been helpful to some other teams as well. We had some questions in the comments of our reveal video of people who just don't have access to the rings because they're in different parts of the world and shipping would be too expensive. So sometimes you just kind of have to get pretty creative and find different ways of doing things.
Have you guys actually compared these to the actual rings? Like, do you have the actual rings in person now, and how do they compare between the two?
Yeah, I know I haven't seen the actual rings in person, but we left the robot at the shop, and I know that the team was playing around with it a little bit, and they used the actual rings, and it was shooting better with the real AndyMark rings. I think we got it pretty close. I don't know if there's a what percent error we were off on some of those things. I think they were too thick. That was one factor, but
Cool. Kate?
So how do you guys think you've improved over the years doing Robot in 30 Hours?
I would say, like, compared to our first year, we've been able to, like, over the years, and we'll see how this year turns out, but we've been able to kind of come up with some of the robots that are actually, like, that end up competing at Worlds, the kind of initial sketchy design of what ends up being competitive. Like with Relic Recovery, we were working for most of the time on trying to build a one of the dump truck designs, and we just didn't have the right kind of intake wheels to make that work effectively. So I think just we've had, access, as the team has had more access to different parts, we've had access to better parts as we've been doing our design process during the rapid part of it. So
I think also part of it is just kind of knowing how much to try and go for in the 30 hours, getting a feel for it. It's a bit difficult for us, especially because since we're both full-time college students, the Robot in 30 Hours for us means we start at the beginning when the game is released, and then at the end of the 30-hour mark, it means that the robot is done, the workshop is cleaned up, the real video is filmed, and I'm in the car heading back to school. So it's kind of a really compressed timeline, and I think just having the experience of knowing how much we can actually do really helped. So you can see kind of at the beginning that first robot just with the grabber for the foam blocks. Originally, as Joe said, we were going for a more complicated design, but we just weren't able to make it work in that time. So we made a very simple thing just in a little bit of time. So getting a feel for what's actually possible is one of the main ways we've learned.
I think this is something a lot of teams do as well. As their team's longer on, they realize how much they can accomplish in a season, and if they should go for like the full design or just focus on one main scoring element in the game.
Yeah, for sure. Go ahead.
That's a really helpful thing for rookie teams as well. Of if you can kind of start with focusing on one thing and then add in other stuff later as you have the time, that's one really good way to kind of make sure you can do one thing well, and then kind of as you have the time, you can continue to improve.
Yeah, and I think a lot of people have criticism for Robot in 30 hours, Robot in 3 days, whatever, because it feels like we're giving the answers. Like, I've participated in Robot in 3 days a couple of times, and a lot of people say that we're giving the answers to the students. But I think a big part of it is giving a minimal viable concept of what a robot could look like. Let's say you do only have a week left until your competition, and your robot is completely fallen apart. This could give you some inspiration to get something ready for that competition. And I think that's pretty important. So I'm glad that you guys have kept on doing this. I hope you guys will keep on doing it in the future because I love seeing your robots. And I know chat definitely wants to see you more. And Kate, they're having a lot of comments about 731 working with your team. So we'll see about the memes as they continue here on First Updates Now. But thank you guys all for your follows and subscriptions we received today. Don't forget you can subscribe for free if you or your parents have Amazon Prime. Tyler, did we have any shout outs or anything that you wanted to do at the end?
Yeah, thank you for reminding me because I totally forgotten about that. Well, we had a couple shout outs both from Ilan and from Bacon. And it just says fun. Both of them say that. They just both copied each other. So there you go. Shout outs for the stream. And that's redeemed with your fun bucks. If you're watching live on stream, you'll accumulate fun bucks for doing so. And I believe if you sub, I think you get twice as many that accumulate. There's a bunch of other stuff you can redeem it for. And we appreciate including you actually can do enough now to actually raid somebody if you want to in the future as well, if you save up enough. So that's for our truly dedicated people who watch live.
We hope you enjoyed this episode of FTC Recap. If you want to stay connected with what First Updates Now FTC is doing, follow us on Twitter, Facebook, and Instagram @FunFTC, and join our Discord through the link in the chat.
We're always looking for feedback, so reach out to us on the Fun Discord and let us know if you have any ideas for future shows. We want to bring you the content that you want.
And I'll give you a little bit. We've got some really, really cool shows coming up. I've already got the next 2 shows booked out, and we've got some super exciting guests that you're not going to want to miss. And we'll probably announce those in the next couple of days or 2. So on behalf of myself, Kate, and our producer Tyler working behind the scenes, I'd like to thank you for tuning in.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Thanks to all of our co-executive producers on Patreon and Tier 2 Plus subscribers on Twitch, keeping fun loud, live, and independent.